Hello, how are you?
Hello, sir.
Is this Motusi?
Yes.
All right, yeah, that's good. Thank you for attending. It's
Okay.
fine. We'll start. Let's just wait for a few learners, then we start. Just 5 minutes, then 5 past, we start.
Okay.
How did you write the paper one? How was paper one?
Yes. It was challenging few questions, but the calculations were, yeah, it worked. There was just one question which was challenging with the position.
Okay. And then where do you scale yourself? Do you think you got 80 plus or 70 plus?
Maybe 80, yeah, 80 plus.
Right.
Yeah.
Yeah, writing on the 19th. This paper two, isn't it?
Yes.
Yes, I wanted to maybe give the scripts after you've written paper two so that most learners, they don't get stressed because the performance was not good, but we'll see. I'm done marking, so I will see how best I will distribute the paper so that you can see how you performed, so that you can pull up your socks for paper two. All right.
Yes.
And then who is the next one? Who is having the attendance of Edna? Hello? Who is the other one in the meeting? I don't recognize the name. Otus?
Sir,
Who is the other attendant?
I think it's Tumelo.
Or is Tumelo? So,
Yeah, I think.
yes, Tumelo, how are you? Can't. All right, let's start. I will share the recording so that everyone will benefit. I will share the recording on the group as well. So I'll try to share everything on the group. Is the screen sharing now?
Yes, it's sharing.
Okay. All right, let's start with the paper two. This is for the year 2023, paper two for the year 2023. All right, in this question paper, you are dealing with the topic geometry of straight lines and geometry of 2D shapes. So provide the correct name for each of the geometric features A, B, and C, D shown on the diagram. So I told you, how do you know that this is a line segment? How do you know that it's a ray? I told you a ray, it has a definite starting point, which means you know where the ray starts, but you don't know where that line is ending. So this is what I told you in class, that we refer to that as a ray. So a ray has a definite starting point and no definite end point. That's a ray. Then a line segment, which means you know where it's starting at A and you know where it's ending at B. This is what we refer to as a line segment. Then a straight line is you don't know where it's starting from and you don't know where it's ending, just like a number line when you are doing integers. So you must know the difference between a line segment, which is having a definite starting point, and a definite end point. Normally, you know from A to B, which means you are certain that this line is starting from A to B, then it's a line segment. But if it has a definite starting point and no definite endpoint, it's a ray, which means we call that line a ray. Then a straight line, no definite starting point. That's why they are having arrows on the left, arrows on the right, like a number line. So the trick was for you to identify which one is a line segment, which one is a ray. So AB is what we are referring to as the line segment. You know where it's starting from, you know where it's ending. But for CD, it's having an arrow there. It tells you that that is not a straight line, because a straight line has two arrows on both ends, which means it's a ray which has a definite starting point and a definite end point. Any question there, class? If you want to ask something, Motus.
So we are fine. I'm fine.
All right. So there is a geometric relationship between a line segment PR and QS shown in the diagram. So you come, the hint there, we are seeing a right angle. So it's for you to identify which two lines are intersecting each other. What do we mean by intersect? We mean which two lines cut each other. To intersect is to meet or to cut. So which two lines they intersect, or which two lines they are meeting at a point, perpendicular. That's what you are supposed to define whenever you see a symbol of a right angle, which is 90 degrees. So the relationship there, describe. So PR, that line PR, this one, is perpendicular. If you want to write it in words, you can write perpendicular in words, or you can use the symbol for perpendicular, which is this one. The symbol for perpendicular, which is that. So we are saying that line PR is perpendicular to which line? To the line QS. Line QS, which is the bottom horizontal line, that one. That is our line QS. So you use that, that is the relationship. If they wanted to use parallel lines, suppose they want to indicate parallel lines, how are they going to do it? They are going to give you two lines like this. Then they say this is P, and then this is R. This is Q, and then the bottom side, it's S. Then they indicate with arrows going upwards. Those arrows, which tell you that those lines are parallel. Those two lines are parallel. So the arrows which are going upwards indicate that those two lines are parallel.
Parallel.
Yes, so which means they don't meet. If lines are parallel, they don't meet, like that. So if you are given those kind of lines, then you write that PR. You write that PR is parallel. This is the symbol for parallel. PR is parallel to QS. Only for this one, which I have given you, this one. But for the original question, I'm just saying, suppose they change the question. They might change to perpendicular to parallel. You must know all the both ways. So you use that symbol. If you forget that symbol, you are allowed to write as well in words that PR is parallel to QS.
QS.
Yes. Any question there? Where you want to ask before we move on? If it's clear, yes. Is it a question?
No, I was saying we are fine.
Yeah, fine. All right. Give the full name of the shape that fits the given description. So now we are given, it's now 2D shapes. Remember we said geometry of straight lines. What do we mean by geometry of straight lines? We mean parallel perpendicular lines. And we talked about lines which are oblique, which means the ones which are sloping like this. I told you this line is oblique. It's neither parallel nor perpendicular. So I told you about these lines, which are oblique lines, which are, yes, it's slanting. So there are lines which are oblique, And then the other ones, parallel lines, vertical. A vertical line is just upwards. A horizontal line is just that. But if two lines are meeting at the right angle, then they become perpendicular. They become perpendicular. Yeah, so you must know that symbol. If you see that symbol, you know it's perpendicular. If the line is sloping, it's oblique. It's neither perpendicular or parallel, which means it's a sloping line. All right. So we're giving the name of 2D shapes. This is a shape which is three-sided shape that has exactly two sides. That has exactly two sides. Remember, if it's a three-sided shape, what do you call a three-sided shape? A shape with three sides. It's a triangle. And this triangle has two equal sides in length. So what type of triangle is it?
Isosceles.
Isosceles triangle, which is correct. So it's isosceles triangle. If the sides are all equal, for example, let's suppose the sides are all equal like this. What do you call that triangle? If the sides are all equal.
Equilateral.
Equilateral triangle. That's correct. So this one would be equilateral triangle. Equilateral, it means equal sides. Lateral means sides. So it's equilateral. And then if the triangle has two equal sides, we said isosceles. What if the triangle has no equal sides? All sides are different. What do you call that type of triangle, which is like this? All sides different. We call it what? Scalene triangle. Excellent. That's one. It's a scalene triangle. It's a scalene triangle. All right. That's correct. That's correct. So revise those 2D shapes. Triangles, squares, parallelograms, rhombus. Yes. Is it a question?
No.
All right. So revise the 2D shapes, the parallelograms, the kites, they are coming. You don't know which one, isn't it?
Yes.
Yes. So go again to revise those shapes. A four-sided shape with both pairs of opposite sides parallel and equal in length and with no right angle. So most learners, they will run for a rectangle, but a rectangle does not have a what? A rectangle, it has right angles. This shape which we want, it must not have a right angle, but the sides must be parallel, opposite sides, which means this side and that side are opposite. That side and this side are opposite. But we are not having a right angle, which means those angles, they are not right angles. Anything, they can be 20, they can be 70. And I told you that angles of a parallelogram, if this parallelogram is a parallelogram, if you know that this angle is, suppose if this is 110 degrees, let's assume this is 110 degrees. (110 degrees). I told you angles which are opposite each other for a parallelogram, they add up to 180. This one will be 70 what? 70 degrees. They always add up to 180. Do you hear me?
Yes.
Yes. And also 70 is opposite to, let's name our angles for the sake of clarity. Let's name this angle A. Let's name that angle A. Let's suppose this is A, this is B, C, and D. So we are saying opposite angles. The 70-degree angle is opposite this one. Opposite angles are supplementary, which means they add up to 180. So which means also angle B. And I told you, how do you write angle B with a head on top? So angle B will be also equals to 110 degrees. Sorry. You said the opposite angles are equal. So that is 70 degrees. So you must know that. So opposite angles there, they are 70. They are always equal, 70. And those angles which are adjacent, they are always supplementary, which means also this angle is 110 degrees, like that. Opposite angles are equal. You must know that for a parallelogram. It does not have 90-degree angles. That shape, we call it a parallelogram. So take note. And if I'm to ask you, Motusi, what is the difference between a square and a rhombus?
A square have equal sides and form right angles.
Yes, that's correct. Equal sides and 4 right angles. That's a square. What about a rhombus?
And a rhombus does not have 90 degrees angles.
Yes, that's correct. For a rhombus, all sides are equal. They are still equal, but the difference, it does not have a what? A 90-degree angle. That is the same between a rectangle and a parallelogram. A rectangle has opposite sides which are parallel and equal, and it has a 90-degree angle for a rectangle. But for a parallelogram, we do not have a 90-degree angle. Then those are the properties. So I'm happy that we are understanding this. Let's go to 1.4. In each case, say whether the two sides are opposite sides or adjacent sides of quadrilateral DEFG. So which means you are given GD and DE. You are supposed to identify, how do you know that the two sides are opposite? How do you know the two sides are adjacent? I told you, if the lines, they share a same vertex, for example, D, G, so this is D, G, and this side is F. They are sharing a common vertex, which is this one. If two lines, they share a common vertex like this, those lines are adjacent. They are next to each other. Is that clear?
Yes.
So DG and FG, DG and FG are adjacent lines. Why? Because they are sharing the same corner, which is G. They are sharing the same corner, which is G. So for you to identify opposite sides, they don't share the same vertex. For example, this line is not sharing the same vertex with the bottom line. The top line is not sharing any common angle or corner. They don't share any corner. So those two lines, automatically they become opposite sides. Is it clear?
Yes.
Mm-hmm. And then for adjacent sides, we say they share the same vertex. If they are adjacent, they are sharing the same
corner.
corner. Yes. If you see two lines which are not sharing a corner, those lines are adjacent. I mean, if they are not sharing any corner, they are opposite. But if they are sharing a corner like DG and FG, these lines are adjacent lines. We call these ones adjacent. What does adjacent mean? It means these lines are next to each other. Adjacent just means next to each other. So these two lines, DE and FG, they are not next to each other, but they are opposite, which means the other one is there, the other one is there. On top, the other one is at the bottom. Whenever you see two lines which are sharing the same corner or angle, those lines, they are adjacent, which means they are next to each other. So that was the theory which they wanted you to apply when you're answering this question. So now they ask you DG and DE. So DG and DE, So first you must check which sides are being referred to, DG and DE. So now we draw our DG. So this is DG. This is DE. They are sharing, these two lines are sharing the same corner here. So automatically those lines, they become what? Adjacent. They are now next to each other. So GD and DE line, those lines are adjacent to each other. Then the lines DE and GF, DE and GF, DE and GF. So let's sketch those two lines so that you can see properly. So DE is this one. That's DE. And the line GF, the line GF is this one at the bottom. They are not sharing any corner, these two lines. They are separated by lines in between. They are separate, they are not sharing any corner. Automatically it becomes opposite. So those two are opposite, yes. That's how you identify whether lines are adjacent or lines are opposite. You use that method. Yes. Then for number 1.5, use what you know about the sides and angles of quadrilaterals to answer the following question. So that's why I said know the properties of all quadrilaterals. A trapezium, it's also one of the quadrilaterals. A trapezium, it's also a quadrilateral. So you must go again, you revise the properties also of a trapezium. All right, so it has only one pair of opposite sides, one pair of opposite sides which are parallel. This is a trapezium. It has one pair of opposite sides which are parallel.
Parallel.
Yes, but for a kite, this shape which you are having, it's a kite. It's a kite. And the properties of a kite, they tell us that only adjacent sides are equal. What do we mean by adjacent sides? These sides which are sharing a corner, these two sides, which are sharing the same corner F, they are equal. And also those two lines which are sharing the same corner, which are sharing this same corner, which is EF and this, they are also equal. So those two lines are adjacent, they are equal. But the opposite sides, they are not equal on a kite, meaning this side is not equals to this side. They are opposite. They are not. So you must know the properties when you are writing your paper 2 next week. So revise, replay the video whenever you feel like you have forgotten some concepts. So opposite sides, HG is opposite to EF. Those sides are not equal on a kite. And you must know that on a kite we have one axis of symmetry. And the angles which are opposite the symmetry line, this is the symmetry line of a kite. So the property of a kite says the angles which are opposite the symmetry line, these are the angles opposite the symmetry line. They are always equal. If this is 70, this is also 70. Or if this is 50, the other one also is 50. Yes. And once you add all the angles, we said all the angles for quadrilateral, they must give you a sum of 360. This, so we are saying angle E plus angle F plus angle F plus angle H plus angle H plus angle G plus angle G. They must give you a total of 300 and what? 60 degrees. So if you add those angles, you must get 360 degrees. That's what we told you in class. I taught you this because it's a quadrilateral. For a triangle, I say, yes.
Are we multiplying here?
No, we are just adding the angles. I said all the interior angles of a kite, they add up to 360. What do I mean by that? Suppose you are given to say, let's say this angle, they are saying it's 70 degrees, and also this angle is 70 degrees. Then they say this one is 40 degrees. Then they say, find this angle, H. That's what I'm saying. In order for you to find H, you say H is equals to 360 degrees minus 70, minus 70, minus 40. Is that clear?
Yes.
Yes, that's what I'm
Yes.
talking. But for a triangle, we told you that a triangle, all angles in a triangle, they add up to what? 180. So if this is triangle A, B, and C, what we mean angle A plus angle B plus angle C, they must give you a total of 180 what? 180 degrees. 180. What do we mean? If this angle is 100 degrees, don't forget degrees. If this angle is 40 degrees, what is angle C equals to? What is this angle C equals to?
Suggestion.
Why is it? Because already we are having 140.
Oh.
Yes.
It's equals to what?
140.
100 plus 40 degrees.
Hmm.
It's
To
close
get
to 140.
we must add 60 to get our answer.
If we add 60, then the triangle is more than 180. So in order to get C, I told you, in order for you to get C, you say that a triangle, it has a total of 180 degrees minus that 40 degrees, so that you see how much is left from 180 minus 100 degrees. What is the answer?
Oh, yes.
So what is C? C is equals to what? C is equals to what? If you calculate, what will be angle C?
40
Yeah.
degrees.
Yes, exactly, 40 degrees. So if you are in an exam, when you see that all your angles, they are not adding up to 180 for a triangle, then you know your answer is wrong. For a quadrilateral, if your angles, they are not adding up to 360, then you know you are wrong. Is that clear?
Yes.
Yes.
All right. So these are just the theory behind, but we have not answered the question yet. So now let's answer the question which we are supposed to answer. This is just revision of triangles and of quadrilaterals, of the kites, etc. So now let's answer the question for that problem which we are answering. All right. So the question is saying, use what you know about the sides and angles of quadrilaterals to answer the following questions. So the following questions: what type of quadrilateral is EFG? We said it's a what? It's a kite. Yes. Now, what is the length of EF? So you come here, you check EF is this side, EF is this side. And we said adjacent sides on a kite, they are equal. So what is this length of EF? We know that EF is equals to F what?
G.
FG. Because these are adjacent sides on a kite, they are always equal. So if you want EF, you know EF is 35 centimeters. Why? Because the reason it's adjacent sides of a kite, they are equal. Any question?
Yes.
Yes. So which means also this side, it's also 35 what?
Degrees.
not degrees, but length is measured in
Centimeters.
centimeters. Centimeter. All right. Then from there, we are going to the next one. What is the length of GH? So if you know GH, which means you are looking for the other side, which is adjacent to GH, which is sharing the same corner with the GH. So which means this one and
16
this one
centimeters.
are sharing the same corner. So which means they are equal.
16
Those-
centimeters.
Yes. They are equal. So which means also this one is 16 what?
Centimeter.
Centimeters. Any problem? Any
No.
problem? No. Right.
No.
Let's go to number 1.6. So here, look at the following figures and answer the questions below. So here, it's a matter of just checking group A, group B, group C. If I'm to ask you which group is showing congruent shapes, which group is showing similar shapes? Which group is showing congruent shapes?
A shows congruent shapes.
And what did we say about congruency? Congruent, it means exact what?
Size and
Same size.
Same
Yes.
shapes.
Congruency, same size, same shape, isn't it?
Same shape. Yes.
But for similarity, it's same shape, but different what?
Different sizes.
sizes.
Yes, different sizes. Same shape, but different sizes.
Different sizes.
Yes. So in these groups which we are having, which group has a pair of similar 2D shapes? Of similar 2D shapes. Which group? Yes. Of
B.
similar group B.
B.
Why did they mention that? Because group B was having a dot there. Although the diagram is not clear, it's like this. All the angles, they are corresponding. If this angle is a dot, this is also a dot, which means those sides, those angles are equal. And this angle
Yes.
was having one line, which is also same with this line, which means those angles are also the same.
Equal.
Yes. However, we were not told the proportionality of the sides, so we can't conclude on group A and group B. So which group has a pair of 2D shapes which are similar? So group B, they are corresponding. There is a one line there, one line, one circle on top, one circle. That other corner, it has no dimension, which means it's the same with the other corner, which does not have a dimension. So which means it's also, those two shapes are similar, which means they have the same shape. But what is different, it's only the size. So same shape, but different size. It means they are similar. So group B. Which group has a pair of congruent? Congruent, we said exact shape or same shape
and
and
same size.
same size.
Same size.
Yes, same shape, same size. So A, you are seeing that those two, they are of same shape
Yeah,
and
same shape
same
and same
size.
size.
That's congruent. Any question regarding congruency and similarity?
No.
No. Okay, let's move on. So for 1.7, it's saying the polygons, a polygon below are similar. If they are similar, which means they have the same shape but different what?
Shape and same size.
Different
Sizes.
Sizes.
Similar, same shape, different size. Determine the sizes of the following. So the question is now find angle C. Find angle C for now. If they have the same shape. So the trick is that for similar triangles, if you know the interior angles of the other shape, it's exactly the same angle. So if here is 60, there it's also 60. If this is not given, but this is given, or automatically you know that this is 40 and this has to be what? How many degrees?
40.
Foot.
Yes, it has to be 40 degrees. And if I'm to ask you what is y, if they tell you calculate y, what will be the size of y? You know that the angles of a triangle, they add up to 180. So 60
Yeah.
plus 40 gives you 100. For you to make 180, you are short with how much?
80 degrees.
80 degrees. So automatically you now know angle y is 80 degrees. And we know that since those two triangles are similar, which means this other angle, this side angle B, is also 80 what?
Up, up.
80 degrees. So that we can form a triangle always have 180 degrees. Then for number B, it's saying calculate the length B. If these two shapes are similar, which means those two triangles, they have the same shape but different size. So now we are checking.
Yes.
This shape, these two triangles are proportional. What do we mean they are proportional? For you to move from the smaller triangle to the bigger triangle, you are multiplying by a certain number, which is a proportional number. What is that number? From 4 centimeters to 8 centimeters, you multiplied by what?
2.
By 2. So which means that small triangle is half of the big triangle because the scale factor is scale factor 2. Remember, when you talk of enlargement, scale factor 2, which means you are multiplying each dimension on the small triangle times 2 to get the dimension on the big triangle. So if I multiply this one times 2, 3 times 2, I get 6 centimeters here.
5.
4 times 2, I get 8. Then
8.
B times 2, I am getting 10. So what is B?
5.
B is just to be 5. So B is equals to 5. So that's how you attempt this problem. First, you check the base angles or any two sides that are given. From 4 to 8, you multiply by 2 because you are enlarging the shape. It's becoming bigger.
Yes.
So if you multiply by 2, you multiply by 2 all the sides. The scale factor does not change. It remains the same. Once you identify one scale factor, it works for all. So only if the triangles are similar. So 4 times 2 give you 8. 3 times 2, it gives you 6. That's why we say this side is 6 centimeters. So B times 2 give you 10. So if you have 10 here, when you divide this by 2, you get the smaller side, which is 5 here on the small triangle. Any question about how we calculated these values? That B is 5, Z is 6. Any question?
No.
All right. So if there's no question, let's move on. Now we are going to question number 2. Question number 2. So question number 2, it's saying translation of 2 units to the left, 1 unit to the right. 2 units to the left, 1 unit down, sorry. 2 units to the... So when you translate, you are first you'll be given an original shape. So the original shape is this one. That was the original shape. So this is the original shape. This is the original shape in purple, which I'm putting now in purple. This is the original shape. And it's given A, B, C. So first, you must move the 2 units to the left, 1 unit down, all the points. So the A, you move 1, 2 to the left. Now it's here. Then you move 1 unit down, you go down. That's where A prime is going to be. Any question? How we got this point? So you move to the left, then you move down. That is the translation that you are using. Where are you getting this translation? You were told that translate 2 units to the left, 1 unit down.
1 unit down.
1 unit down. So from A, the original shape, you move 1 box, 2 boxes to the left, then 1 box down.
1 box down.
You mark that point and you label that point. It's the image of A. So that A, which you are putting A with the apostrophe there on top, A prime, it means is the image of A.
Yes.
So you do the same for B. So now we have our A. So the A image is here now. You put a dot, you mark it. Then you go to B, you do the same. The original B is this one. To the left, 1, 2, which means
Down 1.
1 down. You mark that point. You call it image of B. It's the image
Yes.
of. So you mark that point. Image of B. You put an image with a prime there. Yeah.
We can write in words.
No, you just write B prime. Don't write in words.
Okay.
You just write B with a apostrophe there on top.
Apostrophe.
Yes, that comma which is on top. Is it fine?
Yes.
Yes.
Then you mark that point to indicate that is the image. Then you do the same for C. You go to C, the original. This is the original C. 2 units to the left, 1, 2. 1 unit down, there. Then you mark that point. You call it image of C. Put a dot there.
C.
So
An
you mark
apostrophe.
C. And then you put that apostrophe, that image. You are saying C prime. That is the image. So the image, we call it a prime. Some they call it image. So that is the image of C under that translation. So you mark that point. So after marking the points, you join the points. So now we are joining A to B like this. You join A to B, B to C, then you join those 2 points. You get your marks. Any problem regarding translate that shape 2 units to the left, 1 unit down. So you are moving 1 point at a time. You move 1 point at a time. After you move that point, you name it, you put a dot, you mark that point. After you are done moving all the points, then you can join like what I've done. Any question?
No, sir.
All right. If there is no question, let's move on. So the reflection in the given line of reflection. So we are given the original image. So which one was your original image? The one without the prime. Always the original image. So the original image is this image, which is not having the primed coordinates. So that is your original image, which is not having primed coordinates. So this is the original image. So let's mark it. That is the original image. So this is the original image. That's the original. Yes. So you are moving this original image, you are reflecting it. You are not moving it. You are reflecting it along a line. So the question is saying reflection in the given line of reflection. Which one is the line of reflection? Always the line that is the dashed line. Dashed. Can you see that line is dashed? The dashed line, solid line. That is the line of reflection. But this one, it's a line of reflection, not of symmetry now. Of reflection. It's different. The line of symmetry, it goes inside the shape. For example, like this. A line of symmetry, it goes inside the what? A shape.
The shape.
Yes. But the line of reflection, it does not pass through the shape. That is the difference. Do you understand now?
Yes.
Yes. The line of symmetry does not, the line of reflection does not pass through the shape. Yes, but the line of symmetry, it's inside the shape. Is it clear?
Yes. Yes.
Right.
Yes.
This is what you do when you are drawing this reflection. You go, let's start with point D. From the line of reflection, you are counting now, going to the left. How many boxes? D. You count the number of boxes from the line of reflection. So which means I'm going to count from here. 1, 2, 3, 4, 5 lines.
There are 5, sir.
So which means if I want to plot the image of D, I must also put 5 boxes going to the right from the line of reflection. So to the right now you
Yes.
put 1, 2, 3,
1,
4,
3, 4,
then you mark
5.
your point D. You do the same. You do the same from the line of reflection. How many lines is C? So you count 1, 2, 3, 3 lines. You also do the same. 1,
1,
2,
2, 3.
then you mark that point. Are you seeing it?
Yes, sir.
Yes.
You always count from the line of reflection going to that image. So which means you are counting from this line of reflection. That is your 0 point. Then going to the left, that's 1, 2, 3.
1, 2, 3.
Then you also go
To
to
the
the
right.
right, count 1, 2, 3. You mark that point.
Mm.
You go to
Yes.
G. 1 unit to the left. Then to the right,
1
also
unit to the right. 1
mark that.
unit.
Yes, you mark. You do the same for F. From this point, 1, 2, 3, 4. You do the same to the right, 1, 2, 3, 4. You mark that point.
3, 4.
Same applies to E. You are counting now. That's 1, 2, 3, 4, 5, 6. You do the same, going to the right. 1, 2, 3,
1,
4,
2, 3,
5.
4, 5, 6.
That is the point. Then once you are
Yes,
done,
sir.
you join the points that you have marked, isn't it? You join those
Yes.
points. So now I want to join so that I form that image. So you are joining. So you are joining this point, that point. Where you were putting dots or stars, you join those points. You join, you join. Then you remove all other things that you were putting. You remove these construction lines. I don't want to see these lines, which we are counting. These ones. You must erase with a rubber, these ones. You must remove those. I don't want to see those lines. I only want to see the original shape. Which original shape? I just want to see one shape only, this one. So all other lines, they must be removed. I just want only the final. Is it clear to Melo?
Yes.
Yes. So I only want to see this final one. Other ones, while you are drawing your things, no problem, but erase. Then you only give me that final one, which is on the right.
The
This
original one.
the image after reflection. This
Reflection.
is
Yes.
reflection. So you want to see the reflected one only. So those lines for counting, don't show me. After you put your lines, erase them. Then just leave the final answer only. Is it clear?
Yes.
Yes.
So that is reflection. And I told you the difference between reflection and the image, I mean the line of symmetry. Line of symmetry, it is inside the shape.
The
This is
shape
through the
But the line of reflection, it will be not
does
inside.
not.
Yes, once they do like this, then you know that object has been reflected. So this is the line
Okay.
of, you see the difference?
Reflective.
Yes. All right. If it's clear, let's go to the 2.13. For 2.13, rotation 90 degrees clockwise around vertex C. And I told you, you must have a protractor, a mathematical set when you're writing this question paper. You are going to measure some angles, you are going to construct angles. So if you don't have a mathematical set, which means you are going to get zeros for those particular questions, you won't score any mark because you are not having all the instruments that are required for you to write the exam. So make sure you buy a mathematical set. if you don't have. If you have lost, make sure you borrow or you can buy on time. And there won't be any borrowing in an exam. So the rotation 90 degrees clockwise around vertex C. When a clock moves, if a clock moves, it moves in this direction. This is the direction that we call clockwise. Then anti-clockwise is this direction, opposite the direction of how the clock moves. So this is anti-clockwise. This is the clockwise direction. Is it clear?
Yes.
Yes. So if you are rotating this object, which one is the object that you are rotating? The original, ABC. So let me draw ABC so that you can see which object. This is A, B, and C. This is the object. So you want to rotate this object about, which means at this point, you are going to turn that triangle while you are holding that corner. When they say about C, you are not changing the position of C. Do you hear what I'm saying? You are
Yes.
just rotating about C. So C is the center of that rotation. So C is going to be the center of the rotation. So if you are to measure 90-degree rotation about C, what does that mean? It means that when you measure with your protractor, you do like this. First, you extend this line. Then you construct a 90-degree angle from here. And they said, which direction are you moving? Clockwise. You are moving which direction? Clockwise. So a clock is always moving in this direction. So which means if I am at this point, I want to measure 90 degrees about angle C or about the point of rotation C. So which means you construct a 90-degree angle. You are going to measure with your protractor. Your protractor will be like this. So from this angle, your protractor will be like this. Then you measure 90 degrees from this line, which is horizontal line. So 90 degrees is somewhere there. Then you put your line upwards. After you are done, you've noticed that you're 90 using a protractor. Remember a protractor? You measure from the left. You are measuring from the left, which means this is the zero mark. Your zero must be here. 0 degrees on the left side, since you are moving anti-clockwise in that direction. You measure 90 degrees while the center is at this point. After you have measured 90 degrees from that point, now you know where your 90 degrees is lying. Then you come and do this. So now we know our 90 degrees will pass through this line. So that is the direction of the 90 degrees from here, from this line. So the next thing now is to measure. If it's 2 units from C to B, you also do the same. It's going to be 2 units also from C to that image of B. So which means from here, I must also going to measure 2 units because you know this is the line of 90 degrees upwards. So if this is 2 units, which means 1, 2 from C to B, it must be the same. Since the triangle is just being rotated, you did not change the dimensions or the size of the length. You are just rotating an object. It does not change its length. So the length remains the same. So 1, 2 units. And then from B to A, which means 1, 2, 3 units. You do the same on the red one. 1, 2, 3 units. Then you join the points like this. So you label the points. This is now the image of B. This is the image of A. This is the image of C. So your marks, I don't want to see the constructions of a protractor. You erase. What I only want to see is the final shape of that triangle. That's where the marks are coming from. Any question?
No.
So
Okay.
yeah, wait. So where can we put the point of the protractor?
Where do you put the point of the
Protractor.
Yes, that's a good question. You put the point of the protractor where it says around which vertex. So your protractor is like this, and it has that point which is there, the center of the protractor, and you have a scale which is starting from 0. Use that scale. How are you measuring? Starting from the left to the right, how the clock moves, right to left. So you are using this direction, measuring up to this mark, 90 degrees. So where are you going to position your center? That's a good question. You position your center here. I'll use a different color. Let's use blue. So you position your center where it says around this vertex, you put it here on the blue mark, the vertex C. That's where C was original. Is it clear?
Yes.
Yes, yes.
Once you position your protractor there, then this is your protractor, this one. And it's like this, it's circular like this. The 90 will be there, 90 degrees. So once you find the mark of the 90 degrees, you put that line, you extend it from this point. Then what is only left, you are using the scale which is starting from 0. You are measuring from this side. Then what will be left is for you to measure the distance from C to B. On the original, it's 2. So which means here I must not extend, I must end at 2 boxes. Then you know it's 2 boxes. But B to A, it's 3 boxes. So which means here I must also put 3 boxes. Then you just join to form a shape. I don't know if it's clear. Motus.
Yes, yeah, it's clear.
Let's move on to number 2.21. State whether the following scale factor will produce a larger or smaller image. Right. You are given a scale factor of what? Of 1,2. Are you going to get a larger or smaller? When you multiply any number times 1,2, if you multiply 1 times 1,2, what do you get, Motus? What is 1 times 1,2?
1,2. Yes, 1,2.
1 times 12 is what?
1 times
Oh,
1 times 12 is what?
12.
Yes. So if I say 1 times 1,2, what is the answer?
1, 2.
It's going to be 1,2.
Yes, it's 1,2. It does not change. So
Yes.
what we are saying, if you multiply a number 1 times a bigger number that is more than 1, you get a bigger number. That's why the scale is bigger here. It's a larger image. The image is going to be bigger. But if you multiply that same 1 by a smaller number, what is 1 times 0,5, which is a half? What is 1 times half? 1 times half.
Half.
Yes, half.
Yes. So whenever you multiply by a number that is less than 0, that is less than 1, that image becomes smaller. So this is a decimal. This decimal is less than 1. So whenever you multiply with a scale factor of a decimal which is less than 1, the image becomes smaller. And whenever you multiply with a scale factor of a decimal or a fraction which is more than 1, it can be 1 and 2/10, 1 and a half, the image becomes what? Bigger.
Larger.
Yes, that is what they are just trying to test you here. Do you know that the scale factor which is more than 1, if you multiply by a scale factor of 1, which means the size is only going to be the same, because we know 1 times 1, is just equals to what?
1.
Yes. So
1.
the image is not going to be bigger. The image is not going to be smaller, but the image is just going to be the same. Yes.
Equal.
Equal. Is it clear there?
Yes.
All right. Let's move to question number 2.3. So for question number 2.3, it's saying use a scale factor of 0.5. 0.5 is just half. So you must use your knowledge that if I mean 0.5, 0.5 just means half. It's half. So they are saying resize that shape. So in other words, if you are using a scale of less than 1, which means you are making that shape smaller by half. So that's what they mean. Make that shape smaller by a scale factor of 0.5, by a scale factor of half. In other words, they are saying reduce that shape which is there by half. So how do you reduce that shape which is there by half? You start like this. Let's start. This side.
The smaller shape.
Yes. This side is how many units? This side is how many units? 2 boxes. So if I reduce 2 boxes by half, it becomes what? 1 box. So you draw your 1 box there. Then you do the same this side. You do the same this side. Let's calculate the length of this side, which means it's 1, 2, 3, 4, 5, 6. 7. Do we agree? There are 7 boxes here. 7. And what is half of 7? Half of 7 is what?
3.5.
3.5. So which means this side I must move 3.5 boxes. So you come 2, 3.5. You end there. You don't reach 4. You end at a what? At a half. Is it clear?
Yes.
Yes. You come to the bottom shape, which is this one. 1, 2, 3, 4, 5, 6, 7, 8. What is half of 8?
4.
4. So which means you count from where you ended 4 boxes. 1, 2, 3, 4.
3, 4.
Yes. Then you come also this side, the right hand side. You know the same length coming from this side is the same with the other side, which means half of 7 is also what? 3.5. So I will start from this half. This is the half. So which means I'm starting from the half, which is half. Then I move again upwards. 3 boxes, which means 3.5, which means this is 1, 2, 3. Then half of these 2, it's 1. That is the 1. What about this distance? How many boxes? 1, 2, 3, 4, 5. What is half of 5? Half of 5 is what?
3.2. 3.2.
5.
Yes. What is half of 5? 5 divided by 2. What is 5 divided by 2?
2.5.
2.5, which is 2.5. So you count 2.5 boxes. So it's 1, 2.5. You end there. Can you see?
Yes.
2.5. That's why this learner got it wrong, because the learner ended at 2, not 2.5. Then same, yes, you do the same on the left hand side, which means here you are saying how many boxes? 1, 2, 3, 4, 5. So which means if I'm drawing this side as well, half of 5, 2.5. So it's 1, 2, you end at half, you join. Yes, you join from there. So this is the image after you have used a scale factor of half. If they say scale factor of 2, which means you are multiplying each length by 2. This length, you increase it by 2, which means 2, it will be now
4.
If they say
4.
scale factor of 0.5, you know that your shape is going to be smaller, because we said if the scale factor is less than 1 as a decimal, it's small. If the scale factor is a fraction like half third, you know that's going to be smaller. If a scale factor is 1, more than 1, it's going to be larger, that image of that shape.
Yes.
Then that will be your shape, you get your marks. Number 3. Number 3 is talking about area perimeter of 2D shapes. One side of an equilateral triangle is 32 centimeters. So now they want you to use your knowledge of equilateral triangle. We said all sides are what? Are equal. Yes. So one side of an equilateral triangle is how many? 32 centimeters. So which means this one is also what? 32. 32. Is also what? 32.
32.
The perimeter. Perimeter, we said, is the distance around a shape.
The shape.
Starting from here, 32 plus 32. 64.
Plus 32.
64 plus 32.
32.
You get
96.
That's perimeter. But don't forget to put the units. Not only 96, you write 96 centimeters. 96 centimeters. Any question there?
No.
90 centimeters. All right. You write 96 centimeters. All right. There are others, I think they were late. Let's see. All right. So them. So it's going to be 90 centimeters. Then for number 3.2, it's saying 1 square centimeter, it means 1 centimeter. 1 centimeter times what?
1 centimeter.
1 times 1, it's 1. Centimeter times centimeter, it's square centimeter. So
Centimeter.
you are supposed to complete this pattern. If you are given now in millimeters, how many millimeters is 1 centimeter?
10.
10. That is the 10 which is here. So 1 centimeter, 10 millimeters. 1 centimeter, 10 millimeters. So it's the same as 10 millimeters times 10 millimeters. What is the answer which I should write down? Tumelo. What is the answer?
If it's 2 centimeters.
It has to be?
If it's 2 centimeters, it's 20 millimeters.
What is 10 times 10?
100.
100. What is millimeter times millimeter? What was
Millimeter square.
Millimeter square. You must know this now. Tumelo. Millimeter square, which is square millimeters. Yes, that is the final answer which is there. Is it clear now?
Yes.
If it's volume, if it's 1 centimeter, suppose it's volume. They say volume is 1 centimeter times 1 centimeter times 1 centimeter. So your answer is not going to be square centimeters, but what will be your answer, Motus? The answer will be 1 what?
1 cubic millimeters. Yeah, centimeters.
And then what will be your answer in cubic millimeters?
1,000 cubic millimeters.
Exactly. It will be 1,000 cubic
millimeters.
with a 3.
Centimeters.
Yes. 10 times 10, 100 times 10. Assuming it was volume, but here it's only what? Area. Is it clear?
Yes.
Let's go to number 3.3. A rugby field has a length of 100 meters. So the goalpost to goalpost, which means where the goalkeeper stands, that is, this one is a rugby field, where there is that goalpost where they score. So those goalposts, they are separated by 100 meters. And the breadth is the width, which is the 69 meters. What is the area of the field, excluding the area behind the goalpost? So which means you are not including the area behind. So area of a rectangle, it's length times breadth. So you write your 100 meters, which is your length. You put your 100 times your breadth.
69 meters.
So I told you when you multiply by 100, it's very easy. 69 times 100, you just add 2 zeros. Then you are done.
Yes.
Meter times meter, it's a square what? Square meter. So don't forget that. What to plant that area, the cost of 20 rand per meter. So now we are having your area which you must cover with grass. For 1 square meter, it costs 20 rand. 1 square meter, it costs how much? 20 rand. So if I want to cover 6,900 square meters. If I want to cover 6,900 square meters, I multiply by what? So we are just multiplying by 20. So you must know how to multiply using the vertical column method. 6,900, we are multiplying by 20. There were learners who multiply in paper 1. Up to now, a grade 7 learner is willing to multiply. We don't expect that. So we said 0 everyone. What is 2 times 0?
0.
0. What is 2 times 0?
0.
0. What is 2 times 8? 2 times 9?
18.
18. 8 carry? 1.
1.
What is 2 times 6?
12.
12.
Plus the one
13.
you carry, 18.
13.
That is why answer is 138. But
1,000.
this is now money. It must have units, which is what?
Rents.
So take note of that. All right, let's go to question number 4. The following rectangular prism. So now we are in 3 dimensions now. If we mean dimensions, what do we mean? We mean length, width, or breadth times the height.
Base.
It's 3D.
Height.
Yes, it's 3D. So length, breadth, and height. So which one is your length? The length is this one. And then your breadth, or any dimension that you choose, you can take the longer one as your length, which is the 8, the 5 as your breadth, your B, then the height, the 2. Still 5.
It's the 2, sir.
Length, breadth, and height. Yes. Now, it's saying calculate the surface what? Area.
Area.
They don't want the volume, they want the surface what?
Area.
So first you must have the formula for the surface area, which I gave you in class. You don't memorize this area for the surface. What do we mean? You are adding this first surface, this one. This is a surface. But there are 2 of them, the front and the back one. Can you see?
Yes.
Yes. So if you want that surface area, that's where we said surface area, the length times the breadth. I mean the length times this height. This is the height times 2. So we are going to say 2 times the length times the height, which means it's the front and the back. Then when you are done, you are taking now the breadth and the height. What do I mean by breadth and the height? Which means you are taking this side now, the front.
Times height.
Breadth times height, times 2, because there are two faces, the front and the back. So we are going to say plus 2 times bracket the breadth times the height. Isn't it?
Yes.
Yes.
Then plus again. What is left now is the top face and the bottom one face. That is what is left now. So the top face, which length am I going to multiply? I'm going to multiply the breadth times the length.
Length.
Because there are two faces, the top and the bottom face, which is this bottom face. That's why I'm multiplying by 2. So I am saying when you say plus 2 times my breadth times
length.
times the length. Then you add all your numbers. 2 times,
Yes.
put your number, you add everything. And once you add, already the answer is there. You must be able to come to this answer when you sit down and revise. And surface area, always the units are in square. If they are meters, square meters. If they are centimeters, square centimeters. That's surface area. Is there a problem there? Surface area.
No, sir.
Yes. So go and revise. I have sent this PDF, this document is already there on the WhatsApp group. So which means after we finish this online class, I will share the recording. Where you don't understand the working, refer to the recording and then you master it, isn't it?
Yes.
Yes.
Then let's go to the volume. Volume is the easiest, which means they're just saying length times breadth times height. The longest side was 8 centimeters. So it's going to be 8 centimeters times 5 centimeters times the height 2 centimeters. So first you multiply the numbers. You say 8 times 5 is 40. You get 40. What is 40 times 2?
8.
Volume is always measured in cubic units, cubic centimeters. So the answer, I must see this square cubic centimeter. This time it's not area, but it's volume. So they must be cubic. Okay?
Yes.
Right. What is the capacity of the rectangular prism in milliliters? You use that conversion that we gave into. 1 milliliter is equals to 1 cubic centimeter. I mean cubic centimeter. Yeah. So that if here I have 80 cubic centimeters as my capacity, the maximum a container can hold, that is the capacity. So here it's just to change millimeters to just 80 millimeters because this is equal. Isn't it? Also know the conversion of liters as well. 1000 milliliters is 1 liter. Okay.
Yes.
All right. Let's move on. Now we are in data handling where we did the stem and leaf. I told you the stem are the numbers which are appearing. So if the number is just a 0, the stem is a 0. If the number is 3, the stem is just a 0 because 03, a number 3 can be written as 03. 9 can be written as 09, which means
09.
the place which is in front is just a 0. That's why on the left side, we are having the stem and the numbers which are in between, inside, we call them leaves. So that one, it's a leaf. Stem and leaf graph. We did that in class.
Yes.
Always separated by that line. And I told you your stem and leaf graph must be having numbers in ascending order. If you are given numbers which are not in ascending order, you must rearrange so that this line always from smallest to biggest, smallest to biggest, smallest to biggest. Don't have a stem and leaf which is not arranged in ascending order. Is it clear?
Yes.
Right. So the following is the stem and leaf display, which represents the amount of money in rands in some learners' purses or wallets. So this was money which was in the learner's wallets. So in one learner's wallet, there was 0 rands. In another learner's wallet, 3 rands, 4 rands, 7 rands, 9 rands. If you are reading this money, it's now 1 and 0, so 10 rands, 12 rands, 14 rands, 17 rands, 19 rands. If you are reading this money, it's 53 rands, 54 rands. You start with the stem first. We did that. That's how you read this stem and leaf. So the question now is saying, how many learners were sampled? You only count this money which was found in the wallets. All of this are the number of learners which were sampled. In other words, by sampling, we are saying the number of learners whom we checked their wallets. How many learners did we check their wallets?
28.
So these are the number of learners. You count.
28.
There are how many?
28.
28.
So you are simply counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
7, 8, 9,
It
10,
reached that one.
11, 12.
Yes, 28. That's how you do it.
Yes.
Where are you counting? You're only counting these numbers, not
The numbers.
you are only counting the leaves, not the stem. You don't count the what?
And you are not adding.
You are only counting the leaves.
Yes.
Yes, you are counting the money which was in the wallet. For how many learners did we check their wallets? We checked the wallets of 28 learners.
Learners.
Right. Maximum amount of money in the wallet. So this is the maximum amount. As we said, we write this in ascending order. So the maximum always starts with a 5 and it ends with a 3. I mean a 4.
That's
So
zero.
if the money starts with
Yes.
a 5 and then it ends with a 4, it's how much?
54 rand.
54 rand.
54 rand. So that is the maximum amount. 54. Then determine the median. The median, we said the median is the number at the, when we arrange our numbers in
Median.
order.
Smallest to biggest.
Number
The
that.
number at the center, isn't it?
Yes.
Yes. So which means if we are having 28 numbers, we are going to have how many numbers on the left? 14 on the left and then 14 on the right, isn't it?
Yes.
So this is how you count the median. If you want to count the median, can you see that this learner did not get it right?
Yes.
Yes, sir.
Yes.
So you see carefully how we are going to find the median. If you are given a stem and leaf, because a median for number which is just straight, it's easy to find. For 28 learners, so the learner which is the 14th one is the middle learner. So let's count together the 14th one. So this is 1, 3, 4,
4, 5,
6,
6,
7, 8, 9, 10, 11,
11, 12,
18.
13, 14.
Can you see?
Yes.
Yep.
The 14th number there is 28, 28. If I'm counting from the smallest to biggest, then you
Biggest.
also count from the biggest going downwards to the smallest in reverse now. You want to find the number at the middle, starting from the top side. So you count. The 14th number, 1, 2.
2, 3. 3,
Is 3, 4,
4,
5, 6,
6,
7,
7,
8,
8,
9,
9,
10,
10,
11,
11, 12,
13.
13.
The 14th
14.
number, are you seeing the 14th number?
Yes, the
Yes.
0, sir.
Yes. So, which means we are having 2 numbers which are at the middle, which are 28 and what? And 30. So I told you, if you have a situation where you have two numbers at the middle, you add them, then you divide by.
2.
So the answer is going to be what?
28 plus 8.
50 what?
8
Then you divide by what?
By 2. Sir.
So which means
28 divided by 2.
20. 29. Are we together?
Yes.
Yes.
So the median there was 29. So which
Nine.
means if we are just having the PDF on the WhatsApp group, we are not having the video, which means this one you are not going to get it right because it's not there, it's not correct on the PDF. So you must also go through the PDF you see. So PDF, the median, the number at the center, when we arrange our numbers in ascending order, the 14th position is being occupied by two numbers. 28 rands and 30 rands are being found to be at the center. So I told you, if there are two numbers at the center, you add them, then you divide by 2. So the median there was 29 rands. Is that clear now?
Yes.
All right. Then for 5.2, it's saying 75 people were asked to name their favorite South African soccer teams. The bar graph shows the results with the 2 bars missing. The number of people that like Ajax, Cape Town, Bloemfontein Celtics, the most are equal.
Are equal.
In the missing.
Drawing the missing bar.
Yes.
Bars.
So what hint you were given that they are equal? The supporters are equal. And how many people were asked? How many people?
75.
75. And then
75 people were asked.
you were told that they are equal, isn't it?
Yes.
Yes.
So the trick, let's listen. The trick was that first you calculate how many people supported Kaizer Chiefs. So you say for Kaizer Chiefs, there were 18, isn't it?
Yes.
18. So here it's 18 for Kaizer Chiefs. Then the ones who are supporting Orlando Pirates, can you see that the bar graph, it's at the middle. It's 14, but it's after 14. So it's what at this point?
15.
15. So that's how you do it. It's 15. Then you go to Amazulu. How many were supporting Amazulu? Check. How many?
6.
6. Before you draw these missing graphs, you come to this one, which is the last graph. You need to check other, which means those ones who were supporting other teams except these ones. How many were they? So you check the graph here. It's still standing at what? 18. I see. Still 18.
Yes.
So those who are supporting other is what? It's 18. So for you to draw the missing bar graphs, you were told that those bar graphs are supposed to be equal. People who are supporting Ajax Cape Town and Bloemfontein Celtic are equal. So first you add these numbers. You see what you are going to get. You add these numbers. What is 18?
18 plus 15 plus 6 plus 18.
18 plus 18 is 36.
Plus 50.
36 plus this 6, it's 42. 42 plus 15, what are we getting? That's a 7, which is 57.
57.
All these learners, all these people who were asked were
57.
57. But we were told that how many people were asked in total?
75.
When we subtract, so that we
Yes.
see how many people were left out. Can 5 subtract 7?
No, we borrow from the 7, becomes the 6, and we give the 1 from the to the 5.
Yes. So when we borrow from the 7 becomes a 1? A 6.
6.
And the 5?
We give to the 5. 15 minus 7.
It's 8. 6 minus 5?
We say 6 minus 5 is 1.
It's 1. So these 18 people who were left out, which we need to draw, are for both Ajax Cape Town and Bloemfontein Celtic. So if they are equal, we divide this by what? By 2.
By 2.
Which means you are going to divide that number by what? By 2.
2.
Which means each will have 9. But on the graph which you are given, can you see that there is no 9?
Yes.
Yeah.
But you know 9 is in between 8 and 10. That is
8
the
and 10.
That's why you need to draw. And when you draw bar graphs, I told you there must be space in between the what?
The numbers.
The bar. Okay.
Between another bar.
Yes.
Yeah. There must be space here in between the bars. There must be space in between the bars. So it was a tricky question, this one. It wanted someone to think. It was not easy. When you are revising, go through it again. It's not an easy question, this one. It wanted someone to think. Okay. Wanted someone to think. Then the last question is saying now you are given the following data. Shows mathematics marks for class A and class B.
And class B.
A and class B. Are these marks put in ascending order?
No.
So first you must
Descending
write
order.
ascending one. Ascending order. I told you. You put these marks for class A in ascending order. Smallest to what?
To
Biggest.
You also put these marks in ascending order. Smallest to biggest.
Biggest.
Yes.
If they say what is the range for class A, you go to class A, you check the highest minus the what? Minus the?
The highest is 94.
Lowest.
The lowest.
Then the lowest is what?
10.
10. Close to 84.
Lowest give you the range. So
And the
you
94. Second, the 94.
the highest after you have arranged the numbers in ascending
Order.
All right. So if you don't, you won't get it correct. All right.
Yes.
Then the
Yes.
last one is saying which measure of central tendency, the mode or median, mean or median will best represent the average of the data. Explain. So if we want the average of the data, which one will be the best? So the median, because the mode, which is not possibly for it to be average since there is a big numbers like 59. So in this case, it was the median which best describes. So you explain. So go and read again about. Now we are left with how many minutes? About 30 minutes. We are going to the question paper for last year, which I sent you on the group to revise, which was having already answers. But I'm just going to only explain. The answers are already there, isn't it?
Yes.
Yes. So last year's paper, we said the reflex angle is just an angle that is greater than what?
180.
But smaller than?
360.
360. So go and revise obtuse angle, acute angle, and the revolution. Two shapes are congruent. We said congruent, you mean they have the same shape and what?
Same size.
And then similarity, if they are similar, they have what?
Same shape,
Same
but
shapes,
different.
but small sizes. Different sizes.
Different sizes, yes. Then number 3, an equilateral triangle has how many lines of symmetry? Here, it is 3 lines of symmetry because all the lines, we are dividing it like this. It divides, then it divides like that. So that's why it's 3 lines of what? Symmetry. Line 1, line 2, this is line number 3.
Line 3. Yeah,
but if it's an isosceles triangle, it only has 1 line of symmetry. For isosceles triangle, it just have 1 line of
Symmetry.
Crystalline triangle does not have a line of symmetry. Does not. All right. An area of a square with sides 10 centimeters. So if it's area and you know it's a square, all sides are equal. So it's 10 times 10.
Yes.
10, 100. Centimeter times centimeter,
100.
square what?
Square
Centimeter.
centimeters.
On the previous question
Square
paper for 2023, they asked about the surface area. Can you see this formula now?
Yes.
Yep.
You don't need to memorize it. You don't need to
Yeah.
memorize. What you just need is just to draw your cube, your rectangular prism. You just draw
Yeah.
your rectangular prism. After you've drawn, you label your sides. This is my length, this is my breadth, this is times my height. Because these shapes, they are existing in pairs, you just put times 2. Why times 2? Length times breadth, which means length times breadth, the base, this one, times 2, bottom and top. Breadth times height, which means the front and the back, times 2. Length times breadth. So we are going to the front face and the back face, which means now we are talking of these faces, which is in the front, which is length times breadth, this front, times the back one, which is this formula. So once you draw your cube, everything comes out. If you try to memorize, you will make mistake. Do you hear me, class?
Yes.
The diagram is an example of a what? What is this type of graph?
Pie chart.
The pie chart. We did this. And I told you when you're measuring, that's when you say that percentage, if you want to see how many degrees, you take 22%. 22% means 1200 times, always times 360 degrees.
Degrees.
Then you get this piece, how many degrees, if they want to ask. We did that.
Yes.
Then for question number 2, I said you must bring a protractor when you are writing this exam. If you don't have a protractor, these questions where you are measuring, you lose marks. And how do you measure that angle? You position your protractor like that. And then using the 0 scale, you want to measure this angle here. So your 0 scale is starting from this side. You are not using this scale here. You are not using this scale. You are using a scale which is starting from 0 because you want to measure this angle. So you can't use this scale. You must use this inner scale, not the outer scale. Do you hear me there?
Yes.
Yes, because you want to measure this angle. So you have to start from 0 degrees. You can't measure starting from 180. You don't measure starting from 1. You measure starting from 0. That's why that angle is 35. Why is it 35? It's in between 30 and 40. So that angle is 35 degrees because it's in between 30 and 40. And when you write, don't just write 35. These are angles. They have units, degrees.
Yes.
Okay. Then now they say draw and label an angle XYZ. This is a reflex angle, and I told you how to draw a reflex. First, you draw 180 degrees. This is 180. So which means from X to Y. From X to Y, 180 degrees. It's a straight line. So how many degrees should I add to 180 to make it 289? How many degrees should I add from this line? 289 minus 1 what? 180. So I must add 100 what?
9.
So which means you are going to measure from this straight line. Now you position your protractor facing downwards like this. Then the 0 mark will be here. You measure 109 degrees. Once you measure, you see 109 degrees somewhere there. 109. So which means your angle, which you want, which you are interested in, is only from here. Starting from this point up to here. Because you are saying from here to there, it's 109. 109 plus 180, which is the straight line. It gives you that total. So you erased all the construction lines. Then you are only left with this. Then you must indicate that from there to there, you write 289 degrees.
Degree.
Any question?
No.
All right. Consider the grid below. So the question is saying PS line, is PS a ray, a line, or a line segment? So you go to PS. It's a line segment. Why is it a line segment? It has a definite starting point, a definite what?
Ending point.
Ending point.
And then draw on the grid the line segment through R that will be perpendicular to PS,
PS.
or TU. So you want it to be perpendicular to P, perpendicular to PS. So it must meet at 90 degrees. So first you must have PS, which is this line. Then you take your protractor. Where it cuts 90 degrees, then you label that line TU, where it's 90 degrees here. So once you don't have the instrument, you won't get it right. So they said that line which is perpendicular, you label it TU. So you write T and U.
U.
Yes. Then the last question is saying draw a line segment. The line that is parallel to PS and label it WX. So PX to PS, if it's parallel, it does not cut. So you just draw it parallel, not touching. You label it WX. Like that. Then you are done. You get your marks. Simple like that. Once you don't label the points, you don't get full marks. What is the correct term?
Yes.
Each of the following parts of the circle with the center B. So this is the circle with the center B. So now we are given that is the center of a circle. AB, we call it the radius. That is the shaded area. It's a sector, this one.
Yes.
The distance around the circle, what do you call it? This distance.
Circumferences.
Circumference. That's correct. If I'm to draw a line like this, what do you call it?
A chord.
A chord. Excellent. Shows you are preparing. Let's go to number 3. A triangle that is a 90-degree interior angle is called a what?
A right angle triangle.
So that triangle which you are referring to is like this. The right angle what?
Triangle.
Right. Then in a quadrilateral below, calculate the angle marked X. So I said all quadrilaterals, they give you what?
360.
360. So if there is a missing angle, you add, you say 360 minus the sum of this 65 plus 85 plus 127, you get the sum. Then that total, you subtract it from 360. Then you get the answer is what? 83.
83
Not just 83, but degrees.
degrees.
Then angles of a triangle, we say they add up to what?
180.
180.
Yes, 180. The triangles below are similar, which means they are proportional. Similar, they are proportional. So what you just need to know, all I told you, if they are proportional, the interior angles are the same. If this is a 90, there is also a 90. If this is 30, also there is what?
33 degrees.
Well, if that one is 33, also here it's what? It's also 33 degrees. So you must know that because they are proportional. And if I'm to ask you, what is this size of this angle? If this is, what is the size of angle A? Angle A is equals to what? How many degrees? There's 90, there's 33. What would be A to make it 180? So you add first 90 plus 33. What do you get? You get 3.
123.
So then
What
one
about the 23?
23. What do you get? What is the answer? What do you 50?
63.
57.
57.
Yeah. No.
57 degrees. So which means this angle, it will be 57. Also this angle,
Oh,
57 degrees.
7.
All right. Then angle C, we said is 33 because those triangles are similar. Then what is the length of EF? The length of EF. So if you are calculating the length now, you are now using the proportionality. How do you use that proportionality? Just the same way we did the previous question for 2023. You are checking which triangle was enlarged, which one was reduced. So the first triangle was enlarged. By what scale factor? From 7 to 21, we multiplied by what?
3.
By 3. And then I told you all the dimensions for this one, you are still going to multiply by what? By 3.
3.
Times 3 to get this one. 10 times 3.
30.
30 centimeters. So which means if you want the length of EF, you are just going to multiply by 3. You get that. You are using the proportionality because they are proportional. These triangles are similar, which means their sides are proportional. They are only differing with the scale factor times. You don't add or subtract here. Always it's multiplication. What is the length of EF? 30 degrees. Then we are done. Then we are going to geometry. You use the same method that we did before. So this one now we are translating how many units to the right?
7.
7 only. So you are describing the translation. First, you were given the two shapes, then they tell you what happened. So you are supposed to indicate this. When you move a shape left or right, we say that transformation is translation. Whenever you move a shape to the left or to the right, that transformation, we call it what?
Translation.
Translation. It's not rotation, it's not reflection, this one. And
Translation.
you have to indicate how many units to the right, how many units down or up. In this case, it depends. No units downward. So it was only 7. You count from P to the image, P prime. You count how many steps. That's 1, 2, 3, 4, 5, 6, 7. So you are moving 7 units to the right. For Q, how many units you count? 1. So you are starting from Q. 1, 2, 3, 4, 5, 6, 7. So you are seeing that 7. From S, 1, 2, 3, 4, 5, 6, 7. So another 7. So that is what is indicating that this shape was moved from the original shape, which is this one, to the image by 7 units. So it's translation. How many units? 7 units. And you must indicate the direction. Is it left, right, or up or down? So in this case, it was just to the right. Is it clear?
Yes, sir.
All right, now we are going to the transformation which is being shown there from A, B, C to A image, B image, C image. You are seeing that shape. Was it rotated or was it reflected? What tells you is the position of A. If A was up, now it's what? Now it's down, which means I rotated 90 degrees anti-clockwise. It's a rotation of 90 degrees anti-clockwise because A originally was there. Now A is down. So we have rotated that shape 90 degrees anti-clockwise around what point? Around that point B. Motusi?
Sir.
Around point what?
B.
Around point B. Yeah. So that was the. Then enlarge the square below. Scale factor 2. Now we are not dividing by half. We are multiplying by what?
By 2.
So the original shape was this one. It was 3 units. So you count 1, 2, 3. What is 3 times 2?
6.
6. So there you put 6. Also, this box is 3. You put times 2, 6. So you are going to draw this shape.
Yes.
So you were given this. You are supposed to draw times 2, which is 6.
Yeah. Yes.
So when a figure is enlarged or reduced, the image it's always similar to the original. It's not congruent. Whenever you enlarge the small figure to this one, the figure, the shape, it's always similar. It's not congruent. They are not of the same size, but they have the same what? Shape and same shape. I mean, same shape, but different what? Size.
Size.
Yes, different sizes. Calculate the perimeter is the distance around the what?
The shape.
The shape. And remember, this one is a what?
A square.
Square, which means four sides, isn't it, which are equal?
Yes.
So if each side is 17.5 centimeters, so you multiply. In paper 1, there were people who were failing to multiply decimals. So 17 times 17.4 times 4. I mean, 5 times 4. So if you multiply 5 times 4, it's 20. 0 carry 2. 4 times 2, 28. Plus 2, 8. 0 carry 3.
28.
1, 3, that's 7. You are only having one decimal. And we say if you get this answer, remove the comma from it. Only one, which means your comma is there. So the answer is 70, 0. But we say that placeholder, you can't tell it. That's why the answer is 70. Hello? Hello?
Hello.
Yeah. Let's finish up. We are only left with 8 minutes. Let's finish up. So 1 cubic meter. All right, 7 minutes. 1 cubic meter, 1 cubic square meter is how many square centimeters?
10,000.
And how do you get those 10,000? You do like this, like what I told you in class. So first,
10.
1 meter. It's like this, 1 meter, 1 meter. Now you are converting those meters to centimeters. You don't memorize this. 1 meter is how many centimeters?
10.
1 meter.
10.
How many centimeters?
10.
1 meter is not 10, but 100 what?
Oh, 100. 100.
Centimeters.
100.
Centimeters. So what is 100 times 100?
10,000.
10,000. Excellent. 10,000. So you put your 10,000 inside, which is 10,000 square centimeters. That's where the answer is coming from. You make your box, you make the conversions. That's how you do it. The same way you were doing it in class. Calculate the area of a rectangle with the length 8 and the perimeter is 24. So this one wanted you to think you were not given the breadth, you were given the what? The length and the perimeter. So you know that my perimeter, the formula for perimeter, it's 2 times the length plus the what? The breadth.
The breadth.
Yes. So which means I don't know what is the breadth, but I'm told that the perimeter is 24. So 24 is equals to 2 times the length, which means 2 times the length plus the breadth plus 2 times the breadth using distributive property. But I know the length. The length is 8. That's why 24 is 2 times this 8. because you know the length. The length is what? Is 8. So
8.
plus 2 times b, that is the b here. 2 times b. You don't know the breadth, you need it. So
Yes.
you calculate, so 24 is equals to 2 times 8 is what? 16.
16.
2 times b is just 2b. Then you use your inverse operations. You remove this 16 from the left, from the right, you put it to the left. So now it will be 24. If it comes to the left, it's the inverse of addition, subtraction. 24 minus 16 is equals to 2b. 24 minus 16, it's 8. 8 is equals to 2 times b. You divide. 2 times inverse of multiplication, division. So this is divided by 2. B is equals to 4. So the breadth is 4 centimeters. Now I have found the breadth. Now you can calculate the what? The area. So this was a tricky question. Most learners, they will just go 24 times 8, then they get it wrong.
Yeah.
First you find the breadth, then you multiply. Right, so we are left with 4 minutes. Let's see how we can maneuver. A rectangular hole has been dug for children's swimming pool. It is 7 meters long, 4 meters wide, 1 meter deep.
1 meter deeper.
Length times breadth times height. You just multiply, you get your volume.
28
1 liter. 1 liter equals to 1 cubic meter. 1 liter, 1 cubic meter. Sorry. All right. The conversion of cubic meter is this one. 1 cubic meter, like this. How many liters, Botus? 1 cubic meter, how many liters? Yeah? Botus?
What?
It's 1,000 what?
Oh.
Meter.
Oh, yeah, 1,000
liters.
meters, please.
1
Liter.
cubic centimeter. 1 cubic centimeter is equals to 1 milliliter. Must know that.
So
Yes.
the conversion is the problem.
Must know that. This one, you must just know it by head. You have not converted anything. So that cubic, you are just changing. Where you are having cubic meters, you are replacing cubic meters times 1,000 liters. That's why the answer is 28,000 liters. All right. All right. So surface area, it came again like last year's question paper. It was the same. Then Elena collected this data. This is the data. What did I tell you about the data? You arrange it in order, isn't it?
Yes.
Ascending order. Smallest to
Biggest.
biggest. And the mean, if you want the mean, sometimes they call it average. What do? You add all the numbers. Then you divide by the total number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So you add everything, you divide by 10. That is the mean. You're adding all the numbers, average. Then 40 people of different ages attended a circus. The ages are, or those are the ages, complete the tally, like what we're doing. If the age is from 10 to 19, we said 1. When you put a tally, it's 1, 2, 3, 4. The 51, you want. You cross. Yes. You slash it. Yes, that's correct. So that is the tally. Nothing was difficult. Histogram, I said you don't leave space in between. It must
In between.
Yes, the variables you must put. Then you put your intervals. With intervals, like the one which we did in the classwork. Intervals. And you don't leave space in what? In between.
In between.
Yes. Is it clear?
Yes.
So this marks the end to our revision. Good luck. Good luck. 7
Yeah.
o'clock. Good luck, guys. Go and nail the exam. I want 100%, please. Let's go and pass. Let's go and
Yeah.
pass.
Yes,
All right.
Yes,
Thank
sir.
you. I'll share the recording on the group so that everyone can share and refer.
so we should finish this question paper tomorrow morning. Monday.
I did not hear you, Casey.
We should finish this question paper on Monday.
We already finished it.
Okay.
Yes, we did 2023 and 2024. We are done. That's why I'm saying go and revise. I'm sharing the video on the group, but we are done.
Okay.
Yes.
And the maths paper one, I'm done marking. Do you want your results?
Yes.
Yes.
All right, I'll share them on the group.
Yes. Okay.
Yeah.
Now, sir, please.
All right.
Yes, sure.
Thank you, sir.
Tusi. Oh boy.
Do kutfuna vita
Wangantamula.
efona manu kuvita ungani itwe vari pata santa ta vanhu hinkwavo.
Yeah.
Yeah. Boy. Ta vanhu hinkwavo. Yeah, me ni file ku ri boy. Yeah, boy. Yeah.
John kume 20 something.
U swi vonile?
Lovula.
Sharp, yi ta swi vona kwala boy.
Yo.